Our topic, as you know, is called permutations and combinations. So what is the difference between a combination and a permutation? Well, with a combination, the order doesn't matter. We're not interested in how we got there. We're just interested in what we got at the end. So, whereas in a permutation, A, B, C would be different to C, B, A, would be different to B, A, C, and so on. In a combination, they're all considered one thing. It's just, oh, well, we have three objects. We have A, we have B, we C. We don't care the order. So if the order's not important, if we're going to put them in a line, how many ways can we do it? Obviously, there's going to be less ways now. Because as I said, AB would be the same arrangement as BA. So where we had two before, we've now only got one. I guess if we look at some examples, and we might be able to pick up how we can work it out. If we've got 5 objects, and I'm going to arrange 2 of them. Now, if it was a permutation, there's all the possibilities. And so we would have said, oh, that's 5p2, and there's 20 there. What I'm going to do is I'm going to cross out all the ones that are doubled up. So I'm going to cross out BA because AB's there. I'm going to cross out CA because AC's there, and so on and so on. So I've got rid of all of those ones. So how many am I left with? Well, I'm now left with 10. What I've done is I've divided by, not just divide by 2, because there was 2 objects. It's the number of ways those 2 objects could have been arranged. So 2 factorial, which, yes, does turn out to be 2. Because the arrangements are not important, we can work out the number of permutations and divide it by the number of ways that we're arranging the objects. Because we're not concerned with the arranging the objects anymore. Let's have a look at another one. 5 objects, arrange 3 of them. Hey, quite a few. In fact, there are 60 there. Okay. Let's cross out the double ones. Well, BAC is the same as ABC, CAB is the same as ABC, and so on and so on. Quite a few we've crossed out. What have we crossed out? Well, there's now only 10 left. So I didn't just divide by 3, because if I divided by 3, we would have had 20. 3 factorial, the number of ways those 3 objects could be arranged if I was interested in the order. So the number of combinations is the number of permutations, but divided by the number of ways you could arrange the objects. So all right, so we've got n different objects then, and we arrange k of them. We're not worried about the order. So number of permutations, so npk, but dividing by the number of ways we could arrange those objects, k factorial. Well, there's the formula. N factorial on n minus k factorial, because that was the formula for permutations, you may remember. But now we're also dividing by k factorial. So on the bottom, you'll notice the 2 numbers will always add up to be n. Always add up to be n. We have another notation for that, nck, so for combination, and you will notice that button should be on your calculator as well. I think usually they put it on the multiplication one on a lot of calculators, so second function and multiplication will work out the number of combinations. So let's have a look at a few examples. This is a classic question, of course. Well, you're too young to play the game yet, but some of your parents might partake in a game of lotto each week in the chance of winning lots and lots of money and retiring early. It's a dream we all have, I suppose. Very few of us actually win. So how many ways can 6 numbers be chosen from 45 numbers? So in that game, I don't know whether you've ever seen it or not, they just draw 6 numbers, 6 balls they are. They have little ping pong balls with numbers on them, and they pull 6 numbers out, and if you happen to pick the same 6 numbers, you win a lot of money. And it doesn't matter which order they come out. So it's a combination. 45C6 different possibilities. So the chance of you winning would be 1 in 45C6. And 45C6, in case you are interested in having a go one day, is 8,145,060. So I guess if you're very patient and filled out 8,145,060 entries, you could guarantee you're going to win. Of course, it costs you a lot of money. I think, there he goes, that's 40 cents a game, I think, at the moment. So it would cost you $3,258,024 to do it, but you could guarantee you're going to win there. Oh, but by the way, the other little rule about Lotto, which you may not be aware of if you're not used to the game, if you're the only winner, terrific. If someone else happens to, you share the money. So the gamble is no longer, will I win? The gamble is now, will I be the only winner? So you still can't guarantee winning lots and lots of money. Committee of 5 people. We're going to form a committee. 7 men and 4 women have volunteered for this committee. So how many committees could we put together? This 5-people committee. No restrictions. So again, if there's no restrictions, we don't really care that they're men and women. It's just 11 people want to go on this committee. So from the 11, we're going to get 5 of them. But when I'm choosing a committee, the order doesn't matter. Right? So it's a combination rather than a permutation. I'm just going to grab 5 people and they're going to be my committee. So 11C5, and that turns out to be 462 possible committees we could form. Well, what about if the committee, like in the really old days when the world was very sexist, and they said, oh, no, the committee can be only male. Don't know why, but anyway. So this time we're only choosing from 7. And see, because of that narrow-mindedness, we now only have 21 possible committees instead of 462. So times got more enlightened, and they said, oh, no. The committee has to have at least 1 woman on it. We've got to be fair here. We need a bit of diversity. So the number of committees, I could go and work out, okay, how many committees have 1 woman on it, how many committees have 2 on it, how many have 3 on it, and so on and so on and so on. But I could use that complementary idea. We've already worked out the opposite. The number of committees that contain at least 1 woman, the opposite would be the number of committees that are male only. So I can say, oh, well, the total number of committees minus the ones that are male only must leave me with all the committees that have at least 1 female in it. So I can go 462 minus 21, and we end up with 441. Ah, yes, there's some popular card games around that concern getting 5 cards from a pack of cards. You may be familiar with some of them. So 52 cards in a regular pack. How many different possible hands is there that I could deal out? So I've got 52 cards, and those of you that do play cards would realise the actual order you're dealt these 5 cards in doesn't matter, because a polite card player doesn't pick up their cards until it's totally dealt. So 52C5 different possible hands we could have. 2,598,960 different hands we could have in whatever game we're playing. So what's the probability? In one of these popular games, there's a thing called 3 of a kind. And that would be 3 cards that show the same number. What's the probability of 3 of a kind? All right, well, we know on the bottom of the fraction we'll go 52C5. That's the total number of possibilities, no restrictions. 3 of a kind. Well, let's look after the condition. The first thing we have to work out is, well, which number is going to be 3 of a kind? And there's 13 different numbers. Well, if you call a jack, a queen, a king, you can think of them as numbers. There are 13 different numbers that we could choose from. Just one of those we want to get as 3 of a kind. So we've chosen which one it's going to be. So that's 13C1. Now, there's 4 of those numbers in the pack. There's a heart, a diamond, a club, and a spade. So of those 4, I want to get 3 of them. But I've only got 3 cards. I need to get another 2 cards now. So from 48 remaining cards, I'm going to choose 2 of them. 48 remaining cards. And you might be thinking, hang on, no. There'd be 49 cards left in the pack, surely. Because a 52 card pack, you've just taken 3. Isn't there 49 cards left? Why are you only choosing from 48 and not 49? Reason? The reason is If I was to go 49C2, I might pick the other one of the 3 of a kind. And if I pick that one out, I don't have 3 of a kind, I got 4 of a kind. So there's only 48 cards I want to choose from in order to get 3 of a kind. Now, those of you that really do play these sort of games will realise that I'm actually including something else here called a full house, but let's not worry about that. This has got 3 of a kind in it. So 58,656. So the probability when we break it down is 94 over 2,915. Sometimes, in order to compare probabilities, we think of them as percentages. It's around about 3%, 3.2% chance. Let's have a look at an HSC question. A 4-person team chosen at random, 9 women, 7 men. How many ways can this team be chosen? So I guess this is the bottom of our probability fraction. Total number of possibilities, no restrictions. Again, doesn't matter that it's 9 and 7. It's just 16 people we're dealing with here. So 16C4 would be the number of different teams we could form. Okay. Part 2 then. What's the probability that the team will consist of 4 women? All right, well, we know the bottom of the fraction will be the 16C4. If it's 4 women, well, then I'm not choosing from the men. It's 9C4 will go on the top of the fraction. And so that will give us 126. So the probability, 126 over 1820, 9 out of 130 for that one. So 10G, so more of, well, similar sort of questions we have been looking at, but with the combinations, now the order does not matter. Right, so it's just selecting objects, creating teams and things like that.